The first way you can do this is rewrite it so that it looks like this. When you square something, you are really multiplying it by itself. 3 squared is 3 times 3. 5 squared is 5 times 5. So 3a plus 4 squared is going to be 3a plus 4 times 3a plus 5. Oops. 3a plus 4 plus 3a plus 4. Sorry. Now, if we want to multiply this, we've talked about it already in previous sections. This would be the FOIL rule. So now if I want to FOIL this mentally, I'm going to take my first term, 3a times 3a. That's 9a squared. My outer term is 12a, and my inner term is 12a. So that means I have 24a. I could think of it also as the same as the outer term times 2. That's going to come up later. But both the inner and the outer were the same term, so I just added them together. Last term, 4 times 4, plus 16. This is my final answer. Notice, it is not just as easy as 9a squared plus 16. Let's square this binomial now, using the shortcuts the book talks about in this section. First thing the book says to do in this section is square the first term, because I know if I'm going to FOIL, it's going to end up being 7u times 7u. So I'm going to square this, and it's going to be 49u squared. Now the middle term is usually the outer and the inner put together. And in this case, the outer term is going to be negative 21u. Now so is the inner term. So I have two terms that are both negative 21u. That makes negative 42u. The last term is going to be this one squared. Negative 3 times negative 3 is positive 9. Now if you don't like this mental way of doing it, go back and watch the last example. You can write it out and use the FOIL approach as well. In this section we are looking for special patterns when you square a binomial. If we go and write all this out, sorry, not write it out, multiply it out, I'm going to use FOIL to do that. In order to FOIL though, I need two terms. And so when you have something squared, you can write it as itself times itself. That would be the long way out. Now to FOIL this, I'm going to get a squared for the first. The outer is 7a. The inner is also 7a. And the last is 49. The patterns that we want to look at when we're dealing with perfect squares like this is that the first term is squared, a perfect square. The last term is a perfect square, and the middle terms that are like terms would make twice the product of those two. So twice a times 7, because my final answer is going to be a squared plus 14a plus 49. So again, perfect square, twice the product of these two. So now it's time to go backwards. And in order to go backwards, we're going to be given the trinomial, and we're asked, is this a perfect square? If this is a perfect square, we mean if we can write it like something like this squared, right, a binomial squared, then we can know how to factor it. But if this is not a perfect square, we cannot factor it. So let's see. Our first check, I'll get rid of these for right now. Our first check to see if this is a perfect square is to check the first term. Is the first term a perfect square? Yes, it is 2x squared. Is the last term a perfect square? Yes, it's 5 squared. Is the middle term twice the product of 2x and 5? And it is, because 2x times 5 is 10x. Twice of 10x is 20. And now for the moment we are ignoring the sign. Okay? So now we can put all this together and say, yes, we know that this is a perfect square. So let's take a look at what needs to go inside these parentheses to write it as a perfect square. I know what the first term will be. It will be 2x. Because 2x and then times another 2x will be this 4x squared. The last term has to be a 5 because 5 times 5 is 25. But how am I going to get the negative 20x? With a negative sign right there. This is a perfect square factored to this. Let's check now if this is a perfect square, and if so, can we factor it? Now, the first thing I notice with this problem is that it's not written in this standard form, and we're going to want to rewrite it. You always want your terms in order from the highest power to the lowest power. And 64 has the lowest power because there is no a there. If you don't do this, our check will not work. So now we need to check. And to do that, the first thing we look at is the first term a perfect square. You betcha. Is this last term a perfect square? You betcha. Is the, and this is the more difficult one, is the middle term, the 16a squared, or sorry, the 16a, is that twice a times 8, the 2 from up here, the number squared? And yes, it is. So this is a perfect square trinomial. So now we go and we write the factored form of it. I know it's a perfect square trinomial. I know the first term is going to be a, so because I need to get an a squared. The next term is going to be an 8 to get that 64. And I know that the 16a is positive, so that will be positive as well. This is my final answer. Yes, it is a perfect square, and that is its factored form. When things start to look more complicated than the original problems were given, you may need to factor out the greatest monomial factor first. And that's what happens in this problem. Right now, this is not a perfect square trinomial at all, because this is not a perfect square. 63 is definitely not something squared, neither is n cubed. So something needs to happen first before we can factor it. And that is taking out the greatest monomial factor, which is 7n. 7 is the greatest number that divides all of these. They all have an n in common, that's why it goes in front. So if I take out a 7n, I'm going to be left with 9n squared minus 12n plus 4. This inside here now could possibly be a perfect square trinomial. Let's check. So for it to be a perfect square trinomial, this needs to be a perfect square. And it is. 9n squared is 3n. Excuse me. 3n squared. Is this a perfect square? You betcha. 2 squared. Now that middle term there, the last thing we need to check is that it is twice 3n times 2. Now this 3n times 2 is 6n. Twice that is 12n. Look at that. We're disregarding the sign for right now. You betcha that works. So that means, yes, this is a perfect square trinomial. So I'm going to be able to, in my next step then, rewrite it like this. The question is, what goes inside here? I know the first term needs to give me my 9n squared, so that's going to be 3n. My next term needs to give me a 4, so it's going to be a 2. Because this is negative, there's a negative sign in between there. So the whole thing factored is right there.